大家好，我是雷声. This is going to be my first talk in Chinese. No, unfortunately, definitely not there. But yeah, that's pretty much where my Chinese ends. I can order my bubble tea, but so I'll survive. Let's put it like that. Yes, thanks so much for joining. I'm Thor. I help developers build. So I work for a little company called Supabase. I know some folks already said they've heard of it. That's great. I have, so the QR code on the left is just the link to that page where I just have the resources basically I'm using for this talk. And then on the right you can ask questions kind of throughout the talk, you know, as you kind of think of them, you can put them in Slido. Yes, this is going to be interesting because I don't have a microphone stand, and I'm gonna. Should I sit down? Should I stand? Not entirely sure. We'll figure it out as we go along. Now, Supabase, yes, open source. That's kind of the theme of the night, so we called it an open source meetup. We're the open source Firebase alternative, if you want to put it like that. It helps with the SEO. You know, a lot of people search for Firebase, so I think that's sort of the main thing there. Probably the same with Notion. That helps with with SEO as well. But yes, so basically, you know, it comes from, we love the developer experience of Firebase, right? If you've worked with Firebase, getting started is super easy. Eventually, it might get a bit hairy. But, you know, it's kind of the idea of taking the developer experience from Firebase and applying it to a relational database. And Postgres, open source relational database, been around for, I think, over 30 years, you know, 3 decades. A fun fact, actually, like it precedes GitHub, right? So the actual management of the Postgres project is kind of via email. There's actually an interesting blog post about sort of how you know, proposals get merged into Postgres. It's quite interesting because it's not on GitHub. But yes, so basically the database is the foundation of everything. So that's Postgres. And we're pretty much all in on Postgres because Postgres is so powerful. It basically is like using a cheat code. So we're using things like authentication. So that's also, we're using a server, an open source service called GoTrue. Was originally built by Netlify. Back in the day for Jamstack sites. We've kind of forked off of that. And the authentication actually sits on top of the database, so all the user data lives directly within an auth schema within your database. And then we're using the JWT with the role-level security policies, which is a native concept within Postgres, to actually restrict access to data. Which means that we can put kind of this auto-generated API layer on top using an open source project called Postgres. Yeah, it's confusing with the names, but REST, you get the idea, Postgres. And that actually allows us to automatically generate REST APIs. We also have GraphQL APIs built in into Postgres with a Postgres extension, and so that's the other exciting part of kind of the Postgres ecosystem there. All right, I probably need to be faster. Okay, let me see if I sit down and kind of move the thing every once in a while. Let's see. Did that work? Okay, sweet. Yes, Twitter, if you're not following us, feel free to do that. But actually, while we're here, so we just launched Supabase Vector on Product Hunt. So let's everyone go to Product Hunt and maybe upvote. That's good. While we're here, maybe we can. Does that work?
Upload it.
Yes. So if you go there and you do that while I tell you about Postgres vector. So who's familiar with kind of building AI applications, embeddings, vectors, kind of all that fun stuff? Anyone? No one? Oh, yes, back there. Lovely. So basically, the idea is that you take kind of something like human language or vision and turn that context into a vector. Did everyone manage to scan the QR code? Then I can go and show you some visuals that help with the explanation. Okay, very good. So if we go here, yeah, let's maybe look at this. So there's a blog post that explains kind of, working with embeddings and vectors in Postgres. And so basically it's kind of this idea here where you're kind of translating, something like human language and the context of human language into basically just numbers, kind of a vector. And if you look at this here, so we have kind of, this is just two-dimensional, right? And say we have something like the cat chases the mouse and the kitten hunts, what does this say, rabbits? Rodents? Ah, there we are. Contextually, that is fairly close to each other, right? You have a cat, a kitten, a mouse, a rodent. And so if you translate this into kind of the vector space, this context will be fairly close to each other, right? Now, if you have something like, I like ham sandwiches, that is fairly far away from kind of the previous two statements. And so if you put this into this vector space, what you can then do is you can perform vector similarity search or kind of proximity search, where you're basically looking, okay, for two vectors to be close to each other, then there is some contextual relationship. And so basically now if you're putting language or images, if you can translate that into kind of this vector space, and you can store these vectors and then perform kind of the search on it, then you can build fairly powerful applications. And so pgvector is a Postgres extension that allows you to store vectors of different dimensions right within Postgres and actually create indexes on top of that data, on top of those vectors, and then perform kind of these search operations within Postgres. And so if you're working with something like OpenAI, where you can turn kind of that context like human language or images into vectors, you can then store that into the database using Postgres or Supabase vector, which is basically a managed pgvector Postgres kind of bundle. Now, obviously, to kind of represent something like visual context or human language, you need a lot more dimensions than just these two. And so you actually have like vectors with, depending on the model, more than 500 dimensions. And obviously that is kind of very big numbers. But we'll just use this for kind of visualizing this. If you look at kind of the docs, so we have some documentation. Supabase vector is sort of the soft launch that we've done now. We have the vector store that kind of allows us to store these embeddings using Postgres and pgvector. There's a Python client library called Vex that kind of takes care of the indexing, creating of the collections, performing queries. So if you've worked with something like Pinecone, which is kind of a dedicated vector database, sort of specialized on vector data, it is kind of fairly similar to that experience where you're creating collections and you're querying those. You're kind of upserting things into your collections. We'll look at an example in a bit. But kind of the exciting part with pgvector is that you can actually, because your data is sort of within, where is it? Is it this? No, that's not. Anyway, you can go through the docs yourselves. But the idea is that you have both your vector data as well as your normal relational data or your files. So we also have unstructured data like file storage kind of as part of the Supabase stack. So everything sort of is coexisting within the same database, the same ecosystem, and all the parts are open source. You can use them separately, or you can kind of bring all the different bits and pieces together, and sort of that's kind of the philosophy within Supabase. Open source, modular, so like each piece you can take on its own, self-host, or obviously then our business model is we host it for you, and we manage kind of the hosted database service for you, and that's kind of where we make the money. Okay, great. So let's actually dive into some examples. And I'm a JavaScript fan, but I hear kind of in the machine learning space, people tend to use Python. What I find exciting about kind of this Python example is that I managed to build it without being very proficient in Python. So I think that's sort of the great thing here. So it's this link, the image search with OpenAI Clip. So it's an open source model, and the interesting thing here is that it turns images as well as text into the same vector space. So this means that you can perform image similarity search, right, by comparing the two vectors of images, for example, but also you can do text to image or image to text. So you can kind of translate between these different environments. And so this is kind of what this looks like. So we're basically putting the image data as well as the text data into the same vector space. And you can see here we have an image of two dogs in the snow, which then the text of two dogs in the snow, those two vectors are very close to each other because the context is kind of the same there. And so what we can do is we have this example. It is on GitHub. It is linked in the example as well. And what we can do is we can run Supabase locally, which is pretty nice. So because it's all kind of open source, it's already running. So, sorry, I'm typing with one hand here. I should say status, yes. So we're basically running the entire Supabase stack locally here. So we get kind of our API URL, we get a GraphQL URL, we have our database URL. So if we're kind of connecting directly to the database, we can use the Postgres URL here. And then also we have a Supabase Studio, and you can run that locally as well, which is quite exciting. So if you're somewhere where you don't have internet, well, you do kind of when you start need to pull down some Docker images. So ideally do that before takeoff. But if you manage to start the service locally and have it running, you can actually develop kind of offline, so to speak. So we have our default project here. We can kind of look at the table editor. We have sort of our public schema. We have a bunch of other schemas. So as I mentioned, we have kind of this auth service that sits on top of the database. And so we have kind of all the tables here in a separate schema there. And so if we now look at this example, let me just open it up in here. And I'm just using Poetry to run this, which is sort of kind of like NPM, but for Python, let's put it like that. And so here I'm just using Vex. So Vex is our Python client for vector handling vectors and embeddings. And so I have here my database connection. So I'm basically just instantiating a VEX client with my database connection. So this is here locally on my machine. And I'm actually using something here. I think this is, it's open source as well. It's called Orb Stack, I believe. Orb Stack, only found this recently. And it's basically, okay, there we go, it's cinema mode now. So it's basically Docker running, sort of Docker optimized for Apple Silicon. So if you have a MacBook with like an Apple chip, then actually this will run Docker a lot more efficiently than, say, Docker Desktop or something like that. And I think it's open source, so that's pretty exciting. And so you can see here, by Supabase start, I have all these different services running here. And then what I can do is I have my seed method. So I create my client. I create a new collection that I call image vectors. And we're using the OpenAI clip model here, which translates our images and our text into this vector with 512 dimensions, right? And then I have my model, so we're using the OpenAI clip model. And then I just have a couple of images just here from, maybe just remember those images. They'll be in the exam later. So this is the couple images we have. They're just from Unsplash. And so we're just encoding them here as a vector. And then what we're doing is we're just using our images collection, and we're just upserting our vectors here. And we can specify some metadata that we can also later use for kind of filtering in the query later on. Right, and then we're just saying, okay, we inserted the images and we are creating an index. So after we're upserting kind of the images, we're basically creating an index to make the vector proximity search kind of more efficient. So let's say poetry run seed. And so we're doing all this, what I just mentioned. We're generating our vectors. We're upserting them into the database, we're creating our index. And so now if we go back to our locally running, so this is running on localhost, kind of our dashboard. We now have a new schema called VEX. Can you see that in the back? Do I need to zoom in a bit more? And then here, this is our collection that we created. So this is our image vectors. You can see we have our IDs. These are our vectors. You can see the column type here is vector. So that's the column type that pgvector allows us to store vectors, I think, of up to 2,000 dimensions, something like that. And then we have some metadata here, which is just JSON-B. So we can use that to filter later in our query. So that's it, right? That was pretty easy. So now we can do we can perform some searches here. Again, we're creating our client. Now in this case, we already have our collection, so we just get kind of a reference to our image vectors collection. Again, we're using our OpenAI clip model. And so now in this case, we're getting a query string from our arguments. We're encoding the query string into the same vector space as our images. And now we're just doing a query with our query vector, which is our text string. We're just limiting it here to the most relevant result. There's kind of other input parameters you can put in there. And then we can also filter on kind of the metadata, where you can just say, okay, we won't only want to look at kind of vectors that represent sort of JPEG images, for example. And then we're just getting our result, and we'll just open up the result. So this is where it comes in handy if you remembered what was in the pictures earlier, because we're going to run some searches. Okay, who wants to start? I think I need to run search. What should we search for? Sorry?
And open field.
Open field?
Yeah.
Okay. All right, and so ideally now, and the reason why I called these 1, 2, 3, 4, there we go. I think that's where you applaud. Now, I mean, right? I think it is quite impressive because, like, if you think about, okay, you use this like on a daily basis. You use something like Google Images, right? And you can just search for like me on a bike, not me, like yourself on a bike, and it actually shows you all the pictures of you on a bike. But the tech behind it, right, is like if you think, okay, how do I actually implement this? Here you go. It's just a couple lines of Python code. Okay, I mean, obviously I could have been cheating here somehow. So maybe, should we try another one? Just throw them out. Laptop. Well, I mean, that's interesting because we didn't have anything that's close to a laptop. So let's see what this model thinks is the closest to a laptop. To be fair, on your lap here, there could be a laptop, right? We don't know. Maybe the model knows a lot more than we do. Now that would be pretty mind-blowing if that was actually the case. Maybe fruit? Let's see. We did have some grapes in there. Yes. So we get our grapes. Anyone? Anything else? We did have a bike in front of a red brick wall. Obviously, if I put that in, that might be a bit too easy. But maybe if we just say vehicle. I think the bike was kind of the closest contextually to what we had as, yes, very good. It's like I practiced this. What else did we have? Okay, we had, so these are sort of both, I guess, flowers. No, I mean, let's see, what happens if we put flower? Anyone has an idea how this model was trained? I don't know. Do we get the, yes, okay. I think that's fair enough.
How about something abstract, like happy?
Happy? Okay. That's true. Like, any predictions? What's happy? That is a happy remote worker working in a field. Fantastic internet connection. They are happy. All right. Yes. So the point I'm trying to make here is obviously, right, like the math behind this is fairly complex. And, you know, like even if you're using something like Pinecone, actually this is kind of a copy of the Pinecone example for image similarity search. But it is quite complex, even still, if you're kind of implementing this with Pinecone. But like for me, I don't have much knowledge of kind of the AI world. I don't have much knowledge of Python, and yet somehow a fun little demo came out, right? And so that's kind of what we're trying to do in general. We're trying to make Postgres more accessible to kind of a broader audience of developers, and here with sort of Supabase Vector as well, we're trying to make it easier to, you know, allow you to build kind of AI-enabled applications. Now, I think the subject of my talk was something like building your own ChatGPT. Obviously, let's quickly end on that one. Build your own ChatGPT here with Deno. So for the, you know, let's go back to JavaScript. Actually, who has here worked with Deno before? A little show of hands. Any Deno fans? Yeah, the Supabase folks. Yeah, that's true. Yeah, I love Deno. They probably have the best swag in the business. Somehow they found someone who can draw the cutest dinosaurs, and yeah, it just works, I think. Yes, there we go. Okay, so we're starting up again. Supabase start. We're starting our database here. I probably should have maybe opened the code before I ran this. This is yeah, well, it wasn't too bad considering how many Docker containers kind of are behind this. So now one difference here is we're using OpenAI to generate embeddings rather than kind of running the model sort of ourselves. So we're just going to the OpenAI API. We have kind of a pre-processing step. So maybe if we quickly look at the repository, you can look at kind of the different sort of things that are happening here. So we have a GitHub action, and basically the GitHub action, anytime we're kind of making changes to our docs. So we have like a bunch of markdown files with kind of context, and we put that context, we generate embeddings for it. Because what we want to do is, if you use ChatGPT and you asked something, to ChatGPT, it doesn't have kind of the context that you're asking this question in, right? And so if we know you're, developing with Supabase, we can actually get the relevant context from the Supabase documentation, give that to OpenAI, and make sure that the answer is actually only coming from this context, meaning that you can get a lot more precise kind of answers where, like if I go to ChatGPT and ask like, what is pgvector? I think the example is like, if I ask, what are embeddings? Then ChatGPT will reply with like, oh, in the concept of machine learning, because it has to set all this context. But if I actually provide kind of the context of this query, I say, okay, we're developing with Supabase, and I ask the question now, what is pgvector? Then it knows the context, and we can provide kind of the documentation that we have, and then have ChatGPT actually provide kind of a concise sort of answer. Okay. And so we are pre-processing our documentation, we're generating embeddings, and we're storing them in the database. And so we can quickly look at where is our dashboard. Here's our dashboard now. This dashboard is now running our other project. And so here, I'm not using the Python client anymore, so this is all JavaScript. And so I just have here in my code base, I have one piece of documentation, which is this markdown file called OpenAI embeddings, and storing embeddings in Postgres. And so I'm just turning this into different page sections here. So basically all the different sections. And then I'm just generating a vector so that I can later perform kind of the search to find the relevant context. And then lastly, what I'm doing is kind of at runtime, basically when someone is asking a query, I then take kind of the query string here. What we need to do is we need to sanitize it, because OpenAI actually has some terms of service where you can't ask the model some crazy things. That's against the rules, because otherwise it will get very rude because it gets trained on all that. So you need to sanitize your query. You have your moderation response. So you're kind of asking basically OpenAI, hey, is this an okay thing to ask? Then OpenAI says, yes, here's the sanitized way. You can ask it. And then we create an embedding. Here we're using, I believe this is GPT-3 text embedding model. And we're now then performing our, we're using kind of a remote procedure call to perform our basically proximity search using kind of the JavaScript client here. So that's something that we'll have to make a little bit easier. With Vex, you saw it was a bit easier to do that. But then what we can do is, we tokenize this. And then this is kind of the important piece. So we're generating this prompt where we're saying, okay, you're very enthusiastic Supabase representatives who loves to help people. That's important, so that the answer will actually be helpful. given the following sections from the Supabase documentation, answer the question using only that information. And so that's kind of the crucial part where we're setting the context to be only the context of our documentation. We're providing the context of basically all the pieces of the documentation that are relevant to the user's question. And then we're putting the question in here, and then we're saying, okay, answer as markdown, including related code snippets. Sending that off to the OpenAI completions endpoint, and then we're just streaming back the response. Okay, and I think I'm running way over time here. So Deno task start, and basically the front end piece to this is fairly small. But what we can do here now is what are embeddings. And so if I fire this off now, we're looking at relevant information in our database. We're sending that off to OpenAI, and then we're streaming back kind of the response. Now, if I put in what are embeddings just into ChatGPT, then it will say, like, in the context of AI and machine learning, yada, 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 it will be a lot kind of longer response. Or I can say, can I store embeddings with Supabase? Let's see if the typo is fine. Yes, pgvector, lovely. And there we are. That's how far I'll go. And thanks so much for joining us tonight. And hopefully you get a chance to play around with pgvector. And if you do, let me know what you're building. Thanks so much. Cheers.